So, still the first day of winter break, and I thought I'd not relax and just record some lessons. So I recorded our first lesson on basic trig review. It's pretty basic, and this one isn't much more exciting other than we're going to talk about all 6 trig functions in detail, and then we're going to get into some application questions. But nothing here is really too tricky, and it's going to be a lot of review, so hang with me. Starting with this first box here is a bunch of trig ratios for right triangles, sine, cosine, tangent, also given in the abbreviated notation, and then also their reciprocal functions, which are cosecant, secant, and cotangent. And you will have to have everything memorized, of course. And this first example is already done for you on your notes, but we are given a triangle off to the side here where they gave me a point of reference theta. It's a Greek letter, theta. And they gave me the adjacent and opposite sides, so they had to do a little Pythagorean theorem, and found out that the hypotenuse was the square root of 234, which reduces to 3 square roots of 26. And then they went ahead and they set up all the trig ratios. Now you will notice that if they ended up with a fraction that had to be rationalized, they went ahead and did that. So like for instance this fraction right here, they canceled the 3's to a 1, and then they hit top and bottom by square root of 26. And they ended up with the reduced and rationalized version of square root of 26 over 26. So we're going to continue doing rationalization for PreCalc, but I did speak with the calc teacher, and she said that they're actually kind of deviating away from rationalization at times in math. So don't panic if you run into a teacher who doesn't care if you rationalize the fractions. So, yay. I'm not going to be one of those though, so my bad. So number 1 is not done for us. Let's go ahead and do this. So we have a triangle. Here's our point of reference for theta. And they gave me the opposite and adjacent leg again. So let's do a little Pythagorean theorem to find the hypotenuse. So the 2 legs added together when they're squared gives us 125, right? So if I square root 125, I will break that down into 25 times 5. Right? So maybe I shouldn't be doing work over break. Maybe this is what's going on. Alright, so this, when I reduce the radical, becomes 5 square roots of 25. So there's my hypotenuse. 5 square roots 5. Gosh. There's my hypotenuse. And now I'm going to come up with the 6 trig functions. And yeah, you do have to write out like the abbreviated version of the trig functions, guys. It's not like you're writing the whole thing. So hang with me. So sine of theta, the cosine of theta, the tangent of theta. And then while I'm setting them up, I just go ahead and put their reciprocals like right across from them. So cosecant is the reciprocal of sine. Secant is cosine's reciprocal. And cotangent is the reciprocal of tangent. Because isn't it easy just to do them kind of at the same time? Or at least reference the original one. Alright, so sine is, here's our angle, remember. Sine is opposite over hypotenuse. So we would start off with opposite over hypotenuse. But then we would have to reduce that radical. 10 over 5 is a 2. Come on, buddy. And then 2 over square root of 5 is not rationalized, so then when you hit top and bottom, numerator and denominator here by square root of 5, you finally get 2 square roots of 5 over 5. So that's the rationalized reduced version of that ratio. Now for cosecant, I would actually back up to this step right here before you rationalized. He's reduced, and then if you just flip over to the reciprocal, then you have the cosecant. Sometimes kids make the mistake of going from the final answer for sine and trying to do the reciprocal of that one, and then they have to re-rationalize, and then things cancel, so it's like a lot of work. Don't do that. Alright, cosine is adjacent over hypotenuse. So 5 over 5 square roots 5. The 5's cancel, but we'd never leave our answer in PreCalc as 1 over square root of 5. We'd multiply numerator and denominator by square root of 5, and we'd get square root of 5 over 5. So again, I'm going to back up to this step right here. The reciprocal secant would be square root of 5 over 1, better known as just square root of 5. Tangent. Tangent has a couple of formulas, but the easiest one for right triangle trig is opposite over adjacent. So opposite over adjacent, better known as dos. Cotangent would be uno over dos. I don't know how to say half in Spanish. Sorry. I took German. Not that I know how to say half in German either, so whatever. Alright, so let's come up. Oh, yeah, I finished that. I thought I did half the problem, but I remember I did it all. Another problem here. It's actually real similar, guys. So If you don't mind, for the sake of like my vacation, I would just assume skip this question, but same step. You gotta do a little Pythagorean theorem to find the missing leg. So this time you have to subtract to find the missing leg. Spoiler alert, it's gross. It's a radical. And then you're going to set up your 6 trig functions the same way. Alright, let's move on. I'm bored. Okay, I'm not going to be any less bored on this question, but it's a little better, okay? So we're going to assume that we have an acute angle for theta. And I want you to find the remaining trig functions. So I have sine, so we're going to have to come up with cosine and tangent. And then while we're at it, let's go ahead and write up something for cosecant and secant and cotangent. Okay, so a little note here, and this is actually written from my mentor teacher, Mrs. Hoffbauer, but she says, I draw, but you can use Pythagorean identities. Me too, lady, me too. And you know what? She actually was my teacher in trig a long time ago, so I do it the same way she does, apparently. I don't like to think that hard, and I'm probably more of a visual learner than anything, so I just draw a little triangle. If you're okay with that, I'm going to do that as well. So let's assume my triangle looks something like this. We got a theta down here. And then the sine is 3 over 7, so that's opposite over hypotenuse. So I'd have to do a little Pythagorean theorem to figure out this missing leg. So x squared plus 3 squared, because it's not a triple, equals 7 squared. And after I do a little work, that's the square root of 40. So that's 2 squared to 10 when you reduce the square root of 40. So they have the sine ratio. The cosine ratio would be 2 squared to 10 over 7, which that is reduced and it doesn't have to be rationalized. The secant, however, when I reverse that fraction around, give the reciprocal, that is not rationalized yet. So you'd have to multiply numerator and denominator by square root of 10, and that would give me 7 squared to 10 over, this is 10 times 2, so over 20. You do have to sometimes be careful about like reducing fractions at the end of these problems, but this one doesn't reduce at all. Alright, and then tangent is opposite over adjacent, so 3 over 2 squared to 10. So we have a similar issue to the last one we did where we have to rationalize. So this becomes 3 squared to 10 over 2 times 10 is 20. Again, doesn't reduce, so just leave it. Cotangent, I'm going to go back to this step here and just give the reciprocal of that one rather than thinking weird. 2 squared to 10 over 3 sounds like a good answer to me. It rhymed. I don't know if I want to discuss the Pythagorean identities and the usage of them, so they're okay. You have to work with fractions if you want to do that, just warning. Knowing a little bit about my kids this year, they don't really like fractions, so. Alright, so same idea here. If you want to use the identities, go for it. I'm just going to draw it out, because at least there's some consistency with what we've been doing the last 2 years in trig. You know, geometry and algebra 2, you've done a ton of trig work. Alright, so here's my mystery angle theta. Secant is a reciprocal cosine, so I'm looking at the hypotenuse and the adjacent. So adjacent, hypotenuse. This is not a triple, so I got to do a little Pythagorean theorem here. 5 squared plus mystery number squared equals 8 squared. So 64 minus 25. Square root of 39 is my missing leg. So I already have secant, so I still need sine, cosine, which I should know because it's just a reciprocal secant, and then tangent, cosecant, they already gave me secant, and then cotangent. Alright, let's do this. Sine is the opposite over the hypotenuse. So opposite leg is square root of 39 over hypotenuse, leave it. Cosine is just the reciprocal of secant, so 5 over 8, which I could have figured out from the triangle as well. Tangent is opposite over adjacent. Cotangent would be the reciprocal of that, which of course I'm going to have to simplify here. Rationalize, I should say. Yucky, yucky. Alright, 5 squared to 39 over 39. Lovely. And then cosecant is going to have a similar issue when I take the reciprocal of sine. I have to rationalize that. But I can handle that. It's one of those weird algebra manipulation things that you're not really sure why you have to do it, and frankly, guys, I'm not sure either. So, alright, moving along. Inverse trig functions. We did a little bit of this on the last lesson, and you did a lot of this in geometry and algebra 2, where you had to undo a trig function, and you use the inverse trig function. So when you were a little baby kid, last year, they were talking to you about using the second sine, second cosine, second tangent button. And what you're really doing is you're applying the inverse function to undo the existing function. Another name for the inverse functions are the arc sine, arc cosine, and arc tangent. We're going to do a lot of work with those later. So maybe we should start using that vocabulary, you know, arc sine, arc. Instead of doing second tan, I always get little kids saying that in algebra 2. Second tan, second sine. It's not what it is. Alright. So here, they set up their trig ratio for cosine, and they were trying to find the missing angle, so they had to undo the cosine function by using arc cosine. And they applied it to both sides of the equation technically, and that's how they came up with the answer of 55.15 degrees. Make sure your calculator is in degree mode if you're wanting a degree answer. So this question, I swear, I think I teach this question every single year in every single class. The Leaning Tower of Pisa. They try to claim that it's like a real-life application question. It's not, because, I mean, you're not going to do this. Alright, so anyways, let's pretend you're in Italy and you want to know at what angle the tower is leaning at. I'm sure somebody monitors this, because if the tower starts tipping so much where it's going to just collapse, and they need to know that. But, you know, a tourist is not going to do this. Anywho, you have your Leaning Tower of Pisa, and if you guys know anything about me, you know that I can't draw. So here we go. Beep. Beep. Totally nailed it. That's your tower. It's leaning. Alright, they want to know what angle it makes with the ground. So they want to know this angle here. So I'm going to do an exterior triangle. Oh, jeez. Can't even draw a triangle today. Okay, I kind of missed my mark, but let's pretend that it actually lined up with the tower. And they tell me some information. The tower is 55.9 meters tall, so that would be this length here, because this is supposed to be the top of the tower. Gosh, this is so bad at drawing. There we go. There's the tower. And then it's 55 meters above the ground. So the vertical height here is 55. And they don't tell you how far away you are from here to here. Who cares? We don't need that, because we just need two legs in order to find the angle. So if this is my angle of reference, I have the opposite and the hypotenuse. So we're looking at a sine function. So the sine of our mystery angle is opposite over the hypotenuse. And then to solve for theta, we'll be applying an inverse sine or an arc sine. Gosh, big golly, -1. To that ratio when you're in degree mode, and you get something, 79.7 degrees. I don't know what that means as far as like safety, but tell the authorities, okay? What a dumb question. Alright, submarines. Oh, this isn't getting much better. Alright, 250 meters below the surface of the ocean begins to ascend at an angle of 22 degrees from vertical. Alright, so the sub is going to be not going straight up to the surface level. It's going to kind of angle its way back to the surface. So if you thought my tower picture was bad, wait till you see my submarine. Ready? It's pretty good. Alright, so he's going to be traveling a 22 degree angle from vertical. So if he was going to travel straight up, that would be, oh jeez, that'd be vertical. But he's not. He's traveling like, oh jeez, like this. So this angle right here is 22 degrees. Oh my gosh, Abruzzo, just quit. So how far will a submarine travel before it breaks the surface? And we know he's 250 meters down. So you can't, oh jeez, can't really tell because I can't draw, but there's a right triangle here. And this angle right here is 22 degrees. And then this depth is 250 meters. And they want to know how far will the submarine travel before it breaks the surface. So this is the path of the submarine. I want to know that. So we're looking at the cosine function. Cosine of 22 degrees equals adjacent. Can't even draw numbers today. You know, I think I should have a rule. How many times I mess up. I need like a threshold, like, okay, if you mess up 7 times, like you gotta quit working today. All right, this time we are not going to use inverse cosine because we already have the angle. We're looking for a leg. We're going to use a cross product. So x times the cosine of 22 equals 250. So we're going to have to divide 250 by the cosine of 22. And I already did this. So I got an answer of 269.6 meters is how far that submarine's going to have to travel. Fascinating. Alright, so, oh my gosh. Can we just have a year where we don't do the ladder against a house problem? Just, guys, it's just so boring. Alright, I'm skipping it. I'm done. I'm the teacher. I can do that if I want. This one's at least more exciting. Okay, so we have a person standing 100 feet from the bottom of a cliff. Here's the person, here's the cliff. Notices the tower on top of a cliff. Ooh, look at that tower. The angle of elevation. And like a surveyor does have, they look like binoculars, but they measure angles of elevation. So this is a thing. You know, it's got a little more application to it. Except this question's a little stupid because it's assuming that he's measuring from the ground and not his eyeballs. So whatever. Let's pretend he's laying on the ground. The cliff is 30 degrees to the top, or sorry, to the bottom of the top of the cliff. Yeah, bottom of the tower. And then when he looks all the way to the top of the tower, it's a 58-degree angle. So someone, wonderful person, measured this drew out these measurements for you. The question is, how tall is the tower? So what we're going to do is we're going to look at this as 2 different right triangles. We've got like this little tiny right triangle here. And then we've got this much larger right triangle. Oh gosh. Right there. And the difference, let's call this A. And then this whole length here, this blue guy would be B. If you would take whatever B is and then subtract whatever A is, that'll be the difference between them. That'll be how tall the tower is. So basically we have to do 2 trig ratios and find the difference between the results. Those of you who are thinking, oh, this is a great law of sines or cosines question. We don't know about that yet. So let's not do that. So for the little triangle, the green guy, let's set up, let's see, I have tangent. I have tangent of 30 equals A over 100. And then when I multiply tangent of 30 by 100, I get 57.7. And then when I set up my ratio for the blue triangle, that's still going to be a tangent, this time of 58 degrees, equals B over 100. So a little cross product action, and you get B is 160.0. And then the tower is this minus this. So the tower is 102.3 meters. It's good stuff, right? So again, very reviewy lesson, and I hope that wasn't too much of a challenge for you at this point, but I know for some of you in Algebra 2, who came from Honors Algebra 2, you haven't done these in a while. So good refresher. Let's get to the good stuff. I lied on my last lesson. I said the next lesson would be angular velocity. That's 2 lessons from that. So next lesson we'll have angular and linear velocity in it.